Hey, Dustin Vanoy here. In my last video, I talked about guidance for Databricks development and a bit about the development process. In this video, I will walk through some explanation and demo of the first 3 of my 7 recommended best practices. So for more overview, for more ideas about the development process, go back and watch that video. It's only about 10 minutes here. And this one will take a little more time and go through demos of each section that I cover. So please subscribe to this channel to keep up with more guidance on Databricks development techniques and other data engineering guidance as we go along. So the number one thing is version control. We'll get into that first in this video. Essentially, we're talking about making sure we've got the right version of code that has gone to production, and we keep track of that historically over time. It also gives us the ability to go work on new things, make mistakes, and roll back very easily even before we hit production. Okay, so talking about version control, let's first quickly cover a little more about how this works. So we'll have a Git provider. In this case, I'm going to use GitHub. Azure DevOps is another common provider. And we would have a branch there, which is where all of our code goes directly before going to production. And so often that branch that we would use is main. That's where our kind of final code that has been deployed and ready for use is. When it's time to work on new capabilities, we would have a feature branch. So for instance, my colleague Kimberly might check out the code from my main branch and go ahead and work on a request for adding additional analysis related to flight delays and additional capabilities around those types of metrics. As she's working, she's committing different things. This is probably over the course of a few days or a week, maybe less. Maybe you get it all done in one day, and you're able to get that through what we call a peer review process. Typically, this is a pull request is the term we'll use, and that actually comes with someone reviewing it and approving it and then merging it into main. At that point, depending on exactly how you decide to break out the steps and environments, it might go to like a staging environment for some quick testing and then very quickly to production within the same day. Other times you might have it kind of sit in a staging or test environment for a bit while additional work happens, right? Before you push that all the way to production. But so if it's going to main, I'm expecting it to go to production pretty soon. Let's say my other colleague Lorenzo wants to check out the latest version of main, do some work. If any other features are getting merged in between, they need to like merge those into their own feature branch, make sure it's all ready to go by the time they're done. Say he's amazing, gets it done in one commit, pushes it back up, goes through that peer review process, gets merged back into main, and we'd expect that that would go through a staging process and then a production process quickly after. So let me demonstrate this with GitHub and the Databricks integration with Git providers, which includes GitHub, Azure DevOps, GitLab, etc. So from the GitHub side, I have a repository here. I've called it Flights E2E Azure. This isn't an Azure specific demo, but this is a version that actually have a few settings that work within Azure Databricks rather than AWS. It'd be pretty easy to switch them. So when I'm looking at this, I have my main branch, and this would be what I've deployed all the way through. I'm setting this up just slightly different than what I described, where I've also got a development branch, and that's actually where I would check out and merge back to. And so I'd have just a little bit more separation between what I'm about to push to production and some of the feature changes that I might do. So the idea is I might collect several different features, test those together before merging that into main. So if I switch over to my dev branch, I would see different versions of code that have changed at different times potentially. In this case, they're actually pretty in sync at the moment. Now I've got a feature branch I was working on. Naming conventions vary team to team. I was pretty lazy and just called this UDF, which is way too generic, but I was just adding a UDF example to this code base. So you can see I have files that have been modified very recently here, and this code has been changed. I actually might need to push up some additional versions before we follow through with merging this into main. As we look at that, let me go through and show you what this would look like from the workspace integration. Okay, so to take a look at how we integrate with our version control, we actually can create Git folders. And I've got several of them already created. In this case, we're going to work with my Flights E2E Azure GitHub edition. And so I will go ahead and select that. And because it's a Git folder in Databricks, I have this option to switch between branches. So coming back to my UDF features, there's no changes right now that aren't already in sync with version control, so I didn't see anything in my comparison box. if I wanted to come in and make some changes, one thing I could do is go into my source code. I've got my code organized where I've got a set of Python files that are going to be easy to deal with and test and import, all within my flights directory. And so as I go into a specific code set that I've recently changed, I think it's not quite right, I can go ahead and, in this case, I can swap out what I have for my clean time string to go ahead and do an additional sort of concatenation with a colon in the middle. So I'm going from a certain timestamp format to another. Once I'm done with this change, you can see that I could attach this to compute and run it. It's a Python file. Python files run somewhat similar to notebooks within the Databricks environment. So obviously you would have some ways of testing this and making sure it's good. For the sake of time, let's go ahead and go back to my management of my version control. And here I've made those changes. I can see just the very latest set of changes here. It looks pretty good to me. I will go ahead and say, update my clean time string. Now I commit and push, and that's going to get it, get that commit pushed up to my GitHub repository. What that means is that I could either create a pull request from here if I'm ready to merge this into dev, or I could go into the GitHub UI, which is where I'd really do the pull request. The other link will just send you here anyway. It knows that I recently pushed some changes. Actually, if I refresh, I think it's going to show me more recent changes. 21 seconds ago, I've now taken code from my workspace, put it into Git, and now other places like my local IDE or a team member who's working from a different sort of copy of this same repo can pull down this same information. I'll go ahead and create a pull request here. And we're going to compare our UDF branch. Instead of to main, I actually want to do dev because I've got that dev layer before I go to main. So I'm going to say add UDF example is essentially what this one's all about. I could put some more details in here. I will skip that for now. Go ahead and create this pull request. What we'll see is essentially a UI for us to assign reviewers. I'd probably assign one of my team members here in the real world. They will come in, take a look at what all is being changed, make sure everything's following our best practices. I'm not doing anything silly like putting secrets or something in there. And then once they're good with all of that, they can approve and merge the code. So this approval looks a little bit different if you're not the person that already submitted all the code. In my case, I could still leave a comment saying looks good to me. However, I kind of know that I'm wrong already. We'll take a look at that in the next section. Number 2 is running automated code tests. So as I'm writing out code, whether that's PySpark and notebooks, perhaps even SQL code, though that gets a little bit more advanced into how to do it, or it's a little less mature essentially into what practices people use. Testing our code as we build and immediately after making changes is very helpful to the development process. So being able to have some sort of test that you repeatedly do after code changes is super important. I highly recommend trying to move towards automated tests pretty quickly as you mature your development lifecycle. So one thing to know before we get into the hands-on view of the testing is we have different types of tests. Some of these can get named differently depending on who you talk to, but here's how I define them. At the bottom level, kind of the base level, we have unit tests, and these are meant to test a single function. Let's say we're doing a date conversion or some sort of calculation, such as our delay type calculation. We want to test just that calculation with a single unit test, possibly testing some different scenarios, like what happens if we give it null values, what happens if we give it strange values that aren't valid, and of course, testing the valid scenarios. Integration tests then will usually take a little bit longer to run, sometimes be more expensive to run, take up more like cluster resources to process in time. But the idea is that you're testing one step in a pipeline. This might be loading a single table with all of the different transformations that happen there, or potentially like a single notebook that has some related tables, but is still somewhat honed in to where you can do some validation on those results and make sure that things are still looking good after each set of changes. And then finally, we've got our end-to-end test or system test. And this is meant to test like a full pipeline from source to target. So if I've got Kafka or Azure Event Hubs sending me data that I'm consuming, I probably want to include that in my end-to-end test. If I'm writing somewhere besides Databricks Delta, even though it's a little bit outside of the scope of my code, I'd probably want to test that it's making it to that destination environment. And so these may not even run in your development workspace or development environment, but they're probably going to run in staging before you get to production, just to make sure we haven't messed up the way we integrate between systems with the data pipeline that's under test. Okay, that's the basic idea. Let's step in and look at particularly unit test, what that looks like within Databricks. So a lot of times what we will do to better structure our code to make testing easier is we'll want to build reusable functions in PySpark and then import those and use those Python files from our notebooks if you're using Databricks notebooks for your main application or pipeline. This looks, a little bit different if you're using something like Delta Live Tables, but it's the same idea. You can import a library of code and then reuse it. So if I am doing that type of development, a lot of times for the library development, I will actually choose to use my IDE, such as Visual Studio Code, which has a really good Databricks integration. I talk a lot more about that in some other videos you can go check out if you want to know all the different stuff it does. But let's take a look at how we can use really Visual Studio Code. It looks really similar from PyCharm. They just have a different test tool to run a set of unit tests, see these results, and then make fixes and make sure it's ready to go up to our Databricks environment. So if I go and run all of my tests, the way I've got this configured is I've organized these under a test directory. The VS Code knows where to find them, and it's going to use Databricks Connect. So it's actually running the majority of this code against a Databricks cluster or serverless compute. What that means is essentially once it gets to where it needs to use Spark, I'm going to use Databricks Connect for that piece. And I highly recommend doing that. The reason is you reduce the amount of differences between when you run these tests, whether they're unit or integration tests, but you're kicking them off outside of Databricks. You reduce how much difference there is between that and when you go and actually run this from Databricks. If you choose to do your Python file development and your notebook development all within the workspace, that's a great option as well. There's a lot of really good editing tools there, including the Databricks Assistant to help you out. In that case, you wouldn't so much need to use Databricks Connect for this type of testing. Okay, so I've got a failing test and I've got some passing tests. Let me just show that. I do have a couple of passing tests here besides this fail. This one, I knew it was going to fail when I made the last change we were looking at. So I can jump to that failed test. And really, you have a few different options to view it. I actually tend to look at the test results because I've been doing pytest from a bunch of different environments like PyCharm and Terminal for a while. So I can see I have an assertion error. This is actually not using Spark at all. I was able to do a comparison of two strings and I found that I expected to get 0222 for my time. And instead I got 02 with a colon in the middle, ending in 22. Okay, so my expected and my result were different. Let's go fix that. In this case, the actual expected is wrong, and I want to update my test itself. So I can do that right here in this file. My input, by the way, before I applied this little function, which the logic of the function is not the point of all this, but it was just 3 2s, and the idea is that that's 222 timestamp, right? So I'd expected before that I wouldn't bother adding a colon to it, but then I decided, you know what, it's actually easier to split hours and minutes based on colon. Here we go. I can save that. And then essentially I can go and just rerun the test only for this function. So this is where we see our unit test really coming into play and helping me out as a developer. It very quickly, just with Python in this example, ran a single test instead of having to rerun some, workflow or some much broader set of tests every time. So I would make changes to functions, fix the test to match what it should be doing, make sure everything's green, and then, kind of do one function at a time. And then once I'm ready to say merge this, push this to my dev or my main branches, I'd want to go ahead and make sure all of these unit tests run. A lot of times as a developer, I'll run them locally first just to save time. And then we'll have some sort of automation that will run them all together. But before we start getting too much further in the automation side, let's keep looking at some other examples that testing Spark actually looks a little different than this case, which was just Python string manipulation. So now I've got my flight transforms test. Let's go ahead and hide some things so we can see better. In this test, because of the way my project's structured, I've got, you might remember this from prior videos if you've been following along, I have a source folder, SRC, and that's where I put both my notebooks, a Python runner I've got, and my library of code that I can import via relative path. And so when it comes time to test, I put those into a top level test folder. I choose to do an extra layer here to split out my test a little bit more. And so this repo is set up to make sure you have the right paths with this exact setup. Okay, so if I'm dealing with my flights transforms, I actually need to make sure I append that source path before I start importing any of my flights data. So that's what this is about. If you're set up the same way with the SRC folder, add this to your testing code. As we get into some more specific things, we would need some sort of Spark session over and over again. In this case, I defined it at the module level. And I've got a little bit of logic here, but the core piece that you want to know is that if you're using regular classic compute, you would need to return a Databricks session get or create, and then you either set some environment variables or use the Visual Studio Code extension like I've got to tell it where you want to run this code, which cluster to run on. So that's the most basic example, but I've added switches so I can switch it to serverless and things like that. So that Spark session is a pytest fixture. And when I get into my actual data frame type testing, I've structured this code where I've got these transforms that will take in a data frame, do whatever manipulation I choose to, probably focused a bit on one core set of business logic, and then return that data frame with whatever changes needed to happen. So in this case, we've got an expression that's going to basically just do a case statement across all of these different delay times. I think I've got all of them captured. It's possible I need to update this some more, but it gives me some sort of calculated kind of primary delay type to use in my reporting. At the end, I'm just doing a data frame with column statement to apply some more, to apply this function to a new column in my data frame. So I would follow this pattern quite a few times, have several different types of transforms that I might pick and choose from depending on the work I'm doing. Now, I will suggest that if you have a lot of transforms in the same jobs, you probably don't want something like, I don't know the exact number, but let's just say 20 with column statements in the same job. You'd be better off grouping those together a little bit more and doing like one larger select expression or select that brings back all of the different calculations that you want, in which case you need to write this code slightly differently. Okay, with this though, let's say I'm doing 5 or 10 of these with columns, I'm probably okay for most of your data sets. I can go ahead and take a look at how I tested that. So to test the valid case, like the happy path, I went ahead and did use my Spark session that was a fixture. We just talked about that, and it's using Databricks Connect. I created a data frame out of a Python list. In this case, I've got a bunch of different combinations of delay types. Okay, and then I've got an expected data set, which is the single derived column I'm going to get, the delay type column. So for each of those rows, here is what I expect to get in the results. As I come down to look at building up that expected data frame, it's pretty straightforward. Do it like that. Say result data frame's already been built, or input data frame's been built. Instead, I can say, here's my result data frame, pass in input, apply the transformation that's under test, and then give me the result. Now, here's where we get into some more modern Spark capabilities. We have assert data frame equal is actually built into PySpark. And so we're going to compare 2 data frames here. And there are a few different options you have here. If you need to go more detailed, have more control over how this does the comparison than what's provided with the package I'm using, you could go check out the Chispa library by Matthew Powers. That's got some really good capabilities and has been, I guess, expanded a little bit beyond what's built into PySpark so far. That built-in capability, though, if that has everything you need, might as well just use what's built into PySpark. That's under PySpark testing utils. And then we have 2 different options, the assert data frame equal and the assert schema equal. So at the end of this, it's going to compare 2 data frames, and my expectation is that these match, and they did. That's why I saw the green check marks when I ran these tests before. So you'd end up with probably quite a few of these. Some people might say, hey, since we're reaching out to Spark and Databricks here, they're going to take a little bit longer to run, which is very true. Some people might group these as integration tests rather than keeping them as unit tests. I just call them unit test. I have at times had projects where I'll tag them. There's these options of tagging things in pytest so that I can skip them if I just need to run like everything that's local without touching Spark. But typically it's just a part of developing these types of libraries. We're going to need to create data frames, and I think this is your best bet to just let the Spark cluster do it. If you're able to use serverless compute for this, which does have different way of charging, and you want to just make sure you kind of monitor costs, make sure it works within your environment, and keep an eye on things. That's going to give you the fastest startup time when you first need to get a new session, get connected. Okay, so that was a couple examples of tests. One was just simple Python. This one was PySpark. I've got a few more in this repository if you want to look around. Let's take a look at what we do if we want to develop from the Databricks workspace. There's not like a built-in pytest runner there. So instead, you could use a PySpark testing notebook. This one's been built specifically for the types of things we're doing. So you could just go in and choose run all, and it'll run all the tests. Let's go ahead and take a look. I think I have it failing first, and then I could push up those changes. Let's see here. So we've got a install of pytest, and then we restart the PySpark context. Then we have a simple function to set a few properties, tell it which we'll pass in which path we want to run for each time we run this. And then it's essentially make sure that it fails the way we want to. So without this assertion at the end, you could have errors and your notebook would still succeed, and it just doesn't give you the output that you're expecting. Okay, this is a little helper function. You might need to play with it depending on exactly how your environment's structured. But for me, if I tried to kick this off as a workflow, I was having issues with the path. And so this is what has helped me. If it starts off in the test path already, then I go ahead and change directories and handle some things there. Now, when I get down to running these actual sections, I've got the first path I send is actually a folder of test. This is why I like to break them out so I can have these grouped a little bit when I'm working with the notebook. I run all of my unit transforms tests, which is 2 or 3. Then I run all of my my unit utils test. And here I get an error. This error looks exactly like what we had before because I haven't pushed up the latest code. Why don't we go ahead and push up that code real quick, then we'll test again. Okay, so I chose to use the command line to push that up. Now if I go and just do a run all, it's going to reset the session. Oh, before I do that, we need to actually jump over and pull down the latest. So we're using our Git provider to move code from our local to the workspace and from the workspace to the local. So if I go ahead and pull that down, it's going to then have the changes I need, and I can go ahead and restart this whole notebook. Once it's done, let's take a look at the results and make sure that everything's passing. Okay, so now that that's completed, we have our passed message and our unit utils. So I would say right now from my testing today, this does change often. I'll probably make changes to this in the future. Using this notebook from within the workspace is working really well. If I go and try and schedule as a workflow, sometimes I need to manipulate the path a bit more. And so this is what I've had working in the past. You might need to play with how do we change the directory and append our source path correctly to the path, depending on how you run this code. But if you're going to run from local, my encouragement is go ahead and use those built-in pytest utilities that your IDE will have for you. So let's take a look at an integration test in action. If I go to my test directory, I did have this integration folder, and I've actually got kind of the components of a validation test. So what we will end up doing is for an integration test, we can have a setup notebook, then we can run our actual table creation and updates from our regular notebook, our main application that we would run in production, and then we'll run the validation notebook to make sure everything is good. So let's go find where this is configured. If I go to my workflows section, I have a deployment of the notebook validation job. And I go ahead and kick this off. As it's running, let me give you a quick rundown of what's going on. So we've got 3 different tasks here. And really, we've got a setup task. Then we have the regular job itself, which does this on a schedule. And then we have the validation steps. If we go look at what the validation steps are doing, the setup, by the way, is dropping the table if it already exists from our validation schema. And there's some parameters to pass in. Validation itself is going to, again, take in a schema parameter so we can run it across different environments and different users if needed. And then it's going to, again, use our assert data frame equal type logic, except the big difference is instead of creating the kind of input data set on the fly, we're actually going to read from the table that our main notebook writes to. So we read the table that will be updated by the pipeline. We build some sort of expected data frame to compare to, and then use assert data frame equal again to compare like the counts or the results of some sort of specific query. In addition, we could have pretty simple asserts if we know the number of rows we should expect from our test data set. If we know anything else about how this data should look, we can add those assertions here. So that's the idea of integration tests via workflows. One of the really good things about this is that pattern also works for Delta Live tables. So in my notebook validation run, I had success, which just means that I did my setup, I ran my main notebook, and then the validation was all successful because all of those criteria were met that we just looked at. So other than following our integration workflow example, let me show you another way you can test Delta Live tables. So if I go into my section for my Delta Live tables pipelines, I can find I've actually got a validation job. What is special about validation versus my production DLT pipeline is that I have one of my DLT notebooks. Maybe there's only one notebook in my pipeline, but I have one of my DLT notebooks, and then I have an extra set of notebooks that is only for testing, which is my DLT test. So if I go look at those DLT tests, what we're going to do is use the built-in DLT expectations to add in some special like temporary tables that are going to run some tests for us. So I will put a link in the blog post that's in the description here. I'll put some links to kind of what this pattern looks like to describe it a little bit more. But the idea is that I'm defining a temporary table. I'm defining some DLT expectations here. And if this fails, that means my integration test has failed. When I go to schedule this in production, I would just leave the DLT test notebook out of the pipeline, just run kind of the core code. And then this wouldn't really have anything to do with my production runs. It's only for those validation runs I need to do after making changes or possibly on each deployment. And then number 3, and arguably 2 and 3 could be swapped, but number 3 is deploying this code and the jobs involved to separate isolated environments in order to make sure that once you get to production, you have high quality working system. Now let's talk about scripting our deployments across isolated environments. What we would recommend is to have a separate workspace per environment you want to test in. And in this case, though, I'm just going to show you a way to do it within the same Databricks workspace. So when I look at how I drive all this, I would build it off of Databricks asset bundles. If you have a preference for Terraform, you could use Terraform instead. But I think the integration built into this VS Code extension and also just the simplicity of using this if you're not already very familiar with Terraform is going to make this the way most people will approach this. So here is a Databricks.yaml. This is the core of my bundle configuration, but I am going to also be able to include a bunch of job definitions as well. So for example, I am including information from my resources folder, and I've got some additional definitions that we can look at. But real quick, what I want to show is that I define variables that can be changed based on which target environment I'm deploying to. So flights dev is my default, and that's what I'll use when I'm running like my test as a developer. But then when I start going to a test environment or a staging environment, I would swap these with like flights test, flight staging. You can do some complex variables as well. I'm not covering that in this quick overview. So the target sections where I actually define the differences between a dev environment, a test environment, All of these names are just ways that I can reference each of these as I do different types of deployments, whether I'm scripting that deployment or doing it through automated tooling like I'll show you. So when I go and look at deployment, I have a little icon here to deploy, or I can do this through the command line. The importance of being able to do this through Databricks command line is that makes it really easy from whatever automation tooling you use to run the same kind of deploy. But for now, let's just say if I'm doing this manually during my development flow, I would just deploy everything as part of the bundle. And then if I need to run a particular job once, I can kick that off right from here. What really matters about this is, yes, it's nice to have this scripted. It's nice to be able to deploy it to different target environments. But to take it to the next step and really start to hit where we're trying to go with our best practices, I want to add this to an automated pipeline. For that, I'm going to use a GitHub action. So if you're not using GitHub for your repository, you would be using different type of tooling. But this is a good example, and you can find your specific types of code for your environment by doing some searches and just kind of plugging in the Databricks command line where other types of bash scripting could be plugged in. So this is a bit of what the YAML definition for the GitHub action looks like. I'll let you go to my code repository and take a look at it if you want to get really detailed here, and playing with it is probably the best way to get a feel for what changes. But essentially what I have it set up to do is trigger on certain types of pull requests for my dev branch. Eventually I'd probably add one for main that would deploy to staging when I create a PR to main, and then deploy to prod once I merge that PR to prod. So what it does is it does a couple different steps here. The important thing to call out is that it does do some Python setup. It does run my Python test, and I'm using Databricks Connect here. It does do my bundle validation, and that's all part of the first piece of this action. Now for the next piece where I actually do the deployment, I've got a condition in here, and I don't always do it this way, but this is the path that I would recommend at this point. I've got it set up to where only when the merge is completed is it going to do the deployment. And so here it's going to have an additional step where it does a Databricks bundle deploy to the appropriate environment, and then it's going to do a Databricks bundle run. What that looks like then is if I push up, remember we created a pull request earlier, I'm on the same branch. If I do a push of my latest code changes, it should actually trigger the first step of this, the validation, to run again. Then once we do our merge, we'll see that other step run. So let's go take a look at this in action. I'm on the pull request page. It's actually automatically updating and showing me it's running step 1 of this overall GitHub action. Once that's completed, we can go ahead and merge this to dev and make sure it kicks off the next step. As it runs, you can actually see the details of what's being run, and at a high level, you can see it go through the different steps that we had quickly reviewed in the YAML. Okay. It's actually made it pretty far. It made it through the validate steps, and then it says, nope, I'm going to skip the deploy, and that's because of that condition I showed you. Okay, now we can go ahead, and I'm ready to merge from my UDF branch into my dev branch. When I'm doing something like that, I've actually got quite a few commits involved. I like to do a squash and merge. That's going to say in dev, we'll have one single commit of all of these different changes I made along the way. And here's where I can clean up my my text a little bit about what change that's important to capture. So I think ultimately I would probably clean up a few of these as not being super useful. Like update UDF doesn't tell me a whole lot. I've kind of got that covered elsewhere. Update test is usually good to cover just to call out that you made some changes. With that, we confirm squash and merge, and that's going to do a couple things. One is going to give us this prompt, hey, now that you're done with this branch, you want to go ahead and delete it? And I would probably say yes at this point and delete the branch. More importantly for this discussion is I've actually got my GitHub action running right now. And I'll be able to keep an eye that the deployment completes here. Okay, here we can watch it. I'll just keep it high level. We'll see it complete the test code and deploy. I'll speed it up a little bit and we'll see it finish running the deploy. And one of the steps there was to actually run a validation or an integration test, which is a workflow itself. If I had wanted to move on, kind of the next thing I'd recommend after you have this automation in place and working well is to have a system test, especially when you go to staging, and maybe even run it after you get to production. If you can isolate some validation in a way that you run it after you go to production, you would basically have a workflow that's similar to our integration test, except you'd want to do a little bit less of creating a source table or a source data frame on the fly and actually be reading from a source system, writing to a proper destination system, and including any other like API calls and things that are outside of the scope of the data pipeline in this repo, but are very important to know are working when I'm ready to deploy to production or I've just deployed new code to production. Okay, so we can see it completed, which means everything's good. Deploying to test and running our automated validation. Here's where if we had a desire to move on to production now, we could go back to our repo and go ahead and set a PR to go from dev into main. Once that's checked in, you would need to have some additional action that I don't have in this repo at the moment. It might show up by the time you see this to deal with merges to main and deployment to production at that point. Now I'll say it again, I have Azure DevOps example in a separate video you can go check out. See the blog post and links in the description of this video to just see other examples and information you can access about this type of thing. Okay, you made it with me on this journey through development best practices on this development lifecycle we're talking about. So to recap, what I really wanted you to get out of this is to understand that version control is absolutely important and should be something you're doing today. If not, get started. And obviously I showed you how to integrate that within Databricks. Number two is to be making sure that you can run code tests, preferably automated code tests on the different logical pieces of what you develop, and probably some validation at like a table level or a pipeline level. Number three is being able to deploy that code and the jobs that run them into isolated environments so that you have like a test or staging environment that can make sure the deployment's working, make sure that everything's functioning properly before you go to production, and then make sure that move to production is automated so you don't make silly mistakes like forget to run scripts in the right order or things that I've seen happen in the past. So hopefully this has been useful. I will try to continue to do more deep dives into development related things, especially as Databricks ties into it. Feel free to leave comments or requests for future videos. Obviously I'm just getting to them when I can right now, but I will do my best to help you out along your journey. Thanks for joining. Please subscribe to this channel to be up to date on the latest. See you next time.